let's think about what we would have to do to solve a side-side angle triangle situation. So let's try to draw a general picture of what this would look like. So we know one angle. So let's make that this angle down here. Okay, so this bottom left angle, you have to think of that as being fixed. And we know two sides, so that let's make one of the sides this upper left side. And then the other side, let's make it this right side. And I'm intentionally drawing this as sort of not yet connected into a triangle. So the things that we don't know are, what is this top angle going to be? That's not yet fixed. So we can change this angle at the top if we want to, which will have the effect of sort of swinging this this end of this right side around sort of a circular arc. And also we can change the length of this side on the bottom if we want to make this thing actually a triangle. So with that in mind, let's think about what are the possible situations we could run into. Just to organize our thinking, let's start with this right side being really, really short. So if you have a fixed angle in the bottom left, and a fixed left-hand side, and a very, very short right-hand side like this, you can see that if this upper right-hand side is short enough, then there will be no solutions to this triangle. What I mean by that is there are no actual triangles that satisfy these measurements, the initial angle, side, and other side. So it's possible that there aren't any triangles that we get from this combination of measurements. Okay, what happens if we make this right-hand side a little bit longer? So if the fixed measurement that we have for this right-hand side is longer than the one that I've drawn here, well, you can see that until it gets long enough, there aren't any triangles. But if this bottom left-hand angle is fixed and this left side is fixed, if this, right, imagine this right-hand side, imagine the measurement that we have for this right-hand side slowly getting longer and longer. When it's exactly long enough, it'll just reach the bottom side. Okay, remember the bottom side isn't fixed, so this measurement along the bottom, we can change it to be whatever we need it to be. In other words, we can cut off this extra bit on the right. But if the right-hand side is just long enough, it will just reach the bottom, and when that happens, we'll have a right triangle here. And you can see if you changed this top angle to sort of swing this right-hand side along this arc, there's only one place you can put it that would actually make everything join up to make a triangle, and that's what I have pictured here with this right angle at the bottom. So in this situation, when the right-hand side is just long enough, we should get exactly one solution. Okay, so it looks like what we're going to get, or the character of the solutions for this side-side angle situation, actually depends on what this right-hand side is, or how long it is. So let's see what happens if we make that right-hand side a little bit longer still. So again, we're imagining that we don't know the length of the bottom side, so I'm drawing it extra long just in case we need that length. This bottom left angle is fixed, this left-hand side is fixed, and the right-hand side is longer than it needs to be to reach the bottom. If it just reaches the bottom, then it's a right triangle. But if it's longer than it needs to be, imagine changing the angle at the top to swing this down until it makes a triangle. Well, if you swing it down far enough, yeah, you can make it a triangle. So here is one possible triangle. Right there, there, and there. Okay. But, if you keep swinging this bottom side, if you keep swinging the right-hand side, eventually it will intersect the bottom side again, right there. And that actually gives us a whole new triangle, here, here, and here. So in this situation, when the right-hand side is longer than you need to make a right triangle here, it looks like sometimes you'll get two solutions. That's sort of a new phenomenon, and so we'll have to be careful to see sort of how that works out when you use the law of sines to solve this sort of triangle. Okay, let's make this right-hand side even longer. So we don't know the bottom side, so we'll draw it extra long. The left-hand angle is fixed. This left side is fixed. This right side, so now we're going to make it super long, like this, I guess. And this right-hand side, its length is also fixed. And the top angle we don't know yet. Okay, now when this right-hand side is super long like this, you can see as if you swing it down, you do get this intersection point like we did before. And that gives us one triangle, like that. Okay. So now let's try what we did before and keep swinging the angle. We get like this. You can see maybe it's going to meet up and make another triangle, but this right-hand side, if you make it long enough, when you swing it to the left, it doesn't intersect the bottom side again because it's just too long. It's longer than the left-hand side, and so it doesn't meet up and make another triangle. And so in this situation, we would expect just one solution again. Okay, so this side-side angle situation, it turns out that lots of different things can happen depending on exactly what the measurements are that we're given. You might have no solutions at all, no triangles that fit that description. You might have only one that happens to be a right triangle. You might have two solutions like this, or you might have just one solution but not a right triangle like this. The point of going through all these possibilities is not to memorize the different possibilities, but the idea is just to point out that you really have to be on your guard in this side-side angle situation to not miss any solutions and to not accidentally create any solutions by making algebra mistakes. So we'll look at some examples to see how all of this shakes out and how the law of sines sort of creates or denies these various possibilities.